welcome dear students. Today our intention is many students have asked certain problems as doubts, and in today's video I want to clarify uniformly the doubts of different problems given in your material. Right now, on part of that, this is what the first problem we are having here. Many students have asked, sir, how to do this problem. Right, this is what the doubt of many students. Like here it is given that if cosecant theta minus sin theta equal to a cube, secant theta minus cos theta equal to b cube, prove that a square b square times of a square plus b square is equal to 1. Right, how we will do this particular problem, because many students arise doubts. It is better that if we make one video and clarify all of your doubts. It is good, I thought of it, and we are doing on part of it now. Now this is what first one they have given, that cosecant theta minus sin theta is equal to a cube, like this. Cosecant theta minus sin theta is equal to a cube. This is now 1 by sin theta, like this. 1 by sin theta minus sin theta, right, by 1 is equal to a cube. Like now this is now sin theta. Right, this is equal to now sin theta. You are having here this sin theta is equal to what we will be getting here. If you take LCM, 1 minus sin square theta, right, and this is equal to a cube, and this is now you are having here 1 minus sin square theta is nothing but cos square theta. Cos square theta by sin theta is equal to a cube. You are having like this. In the same way, right, let us take the second one. Secant theta minus cos theta is equal to b cube, like, and the secant theta become 1 by cos theta minus cos theta, right, is equal to b cube. Right, now this is now cos theta into 1 minus cos square theta. This is equal to b cube. You are having it, and 1 minus cos square theta by cos theta, that is nothing but sin square theta by cos theta is equal to b cube. You are having here. Now you have got wonderfully two things, like, right, cos square theta by sin theta equal to a cube, and sin square theta by cos theta equal to b cube. What we do is, let us try to multiply these both. Right, we try to multiply these both and we will see what we will be getting here. This is equation 1 and equation 2 you got here. This is equation 1 and this is equation 2. Let us try to multiply this. This is now cos square theta by sin theta into sin square theta by cos theta. This is equal to a cube into b cube, like this. Sin theta here, 1 sin theta, 1 cos theta. Therefore, from this, what you have got wonderfully from this, right, cos theta into sin theta. Cos theta into sin theta is equal to, you have got a cube b cube, right. You put it this in the box and you call it as equation number 3 requires, like this. Right, wonderful. Till this we have got like this. Okay, fine. Now you know that what cos square theta from equation number 1. From equation number 1, you know that cos square theta by sin theta is equal to a cube sin theta, like this. Right, sorry, a cube you have here, like this, a cube, and from this if you do the cross multiplication, cos square theta is equal to a cube sin theta you will be getting, and from this cos cube theta, if I multiply cos theta on both sides, then we will be getting a cube sin theta cos theta. Right, if you multiply cos theta on both sides, because why I multiplied means, because we know cos theta sin theta is a cube b cube, that's why we have got it like this. Now cos cube theta is equal to a cube into sin theta cos theta is a cube into b cube, like this. This is now a power 6 into b cube, like this. This is now cos cube theta is equal to a power 6 b cube, like this. Right, wonderful. We have got till this cos cube theta equal to a power 6 into b cube. Right, wonderful. In the same way, let us find right sin cube theta. So in the same way, sine from equation number 2, sine square theta by cos theta is equal to b cube. Sine square theta equal to b cube into cos theta. And sine cube theta, by multiplying sine theta on both sides, sine cube theta equal to b cube into cos theta sine theta. Now this is equal to sine cube theta is equal to b cube into, you already know cos theta sine theta is a cube b cube. Therefore, if you multiply this a cube b cube like this is now a cube b power 6. Right? This is what you call it as equation number 4 like this. Sine cube theta equal to, we have got like this, and the cos cube theta, already we told you that we have got it as a power 6 into b cube like this. Okay, this is what we called equation number 5 like this. Wonderful. Now see here, after getting these two things right, we need sine cube theta equal to this and cos cube theta equal to that we have got here like this. Wonderful. Now from this you see my dear students, sine cube theta is equal to a cube, right? What you are getting? A cube b power 6. That means sine theta is equal to, you are going to get a cube b power 6 whole power 1 by 3, right? This is nothing but a into b square like this, a into b square. In the same way, cos theta is equal to, you know, cos cube theta equal to a power 6 b cube, and this become a square b. Okay, yeah. So from this, however, a square b, however, you can write this as whole cube like this. From that, what we can say is cos theta equal to a square b whole cube whole power 1 by 3. That is nothing but a square b like this. Now you got sine theta equal to ab square and cos theta equal to, right, a square b, right? And you know, my dear students, that you know sine square theta plus cos square theta is equal to 1 like this. And this is a standard identity. You know that you substitute in this. Sine theta equal to, now you got ab square, that means ab square whole square plus cos square theta, that is a square b whole square, is equal to 1. From this, if you simplify, what you will get? This is now, right, a square b power 4 plus b square a power 4 is equal to 1. And from this, a square b square if you take common, a square b square if you take common, right, what you will get is b square plus a square is equal to 1. In this way, you have got very beautifully this particular problem, right? Many students have asked for, sir, these problems as doubts. Then I felt that better it is to make a video and distribute to everyone, share it to everyone. The next problem, this problem also many students are asking the doubt, right? This problem, they given that x, y, z, and we need to prove x square plus y square plus z square is equal to r square like this. It is very simple, my dear students. You take as usual left hand side x square plus y square plus z square, you take like this. And this is nothing but now r square cos square alpha cos square beta, because x is r cos alpha cos beta. Then x square is nothing but r square cos square alpha cos square beta. And y square is nothing but r square cos square alpha sin square beta like this, plus z square is nothing but r square sin square alpha like this, r square sin square alpha. Okay, wonderful. Now among all these, my dear students, we can take r square common. Once if you take r square common, they become cos square alpha cos square beta plus cos square alpha sin square beta like this, plus sin square alpha like this, sin square alpha like this. Now this is equal to r square, right? Let us try to simplify this fact, right? Okay, fine. Yeah, if you try to simplify this, here we are having cos square alpha sin square beta. This what I do is cos square alpha, this cos square beta we write it as 1 minus sin square beta like this, plus cos square alpha into sin square beta plus sin square alpha like this, right? Wonderful. This is equal to, now, right, This is r square into this is cos square alpha minus this is cos square alpha into sin square beta minus cos square alpha into sin square beta plus this is now cos square alpha into sin square beta plus sin square alpha like this sin, right? This will cancel now r square into cos square alpha plus sin square alpha, that is a square relation, it is 1, that's why you have got r square, you have taken left hand side and you have got wonderfully the right hand side part. In this way you will do this particular problem. Okay, fine. Okay, now the third problem which is asked frequently, most frequently, this has also a doubt, that's why I took this problem to solve. Okay, today's class videos totally doubts. Okay, we are going to discuss. You see here they given an equal to sin power n theta plus cos power n theta. That means a3, if you take, this is nothing but now sin cube theta plus cos cube theta like this. A3 is this, and A5 is nothing but sin power 5 theta plus cos power 5 theta like this, right? And A7 even, you will be getting A7 is equal to sin power 7 theta plus cos power 7 theta like this, right? And A1 also, you know that sin theta plus cos theta, like, because an they given it as sin power n theta plus cos power n theta, that's why we have got these things. Like, now you take the left hand side part, okay, a3 minus a5 by a1 like this. A3 is now sin cube theta plus cos cube theta minus of a5 is nothing but now directly I will write sin power 5 theta minus cos power 5 theta, whole thing divided by a1 is nothing but sin theta plus cos theta, we have like this, right? Wonderful. This is what left hand side part we have got here, right? And from the sin cube theta and minus sin power 5 theta, what I do is I will take one thing, sin cube theta I can take common, then it become 1 minus sin square theta. The same way cos cube theta you are having here, cos cube theta and cos power 5 theta like this. From those we will take cos cube theta common, then it become 1 minus cos square theta like this, 1 minus cos square theta. Right? Wonderful. Now this becomes sin cube theta into cos square theta plus cos cube theta into sin square theta. We have like this, right? Wonderful. By, okay, this total thing, however, fine, this total thing, whole thing divided by, right, we have sin theta plus cos theta, right? Sin theta plus cos theta, here also whole thing by sin theta plus cos theta actually, right? Fine. Now this, from this you can observe that we can take common, what we can take common, sin square theta cos square theta we can take common. If you take sin square theta cos square theta common, then you will be getting sin theta plus cos theta, whole thing divided by sin theta plus cos theta like this. This will cancel. Now we have got the left hand side part as sin square theta into cos square theta, right? Fine. You call it as equation number 1 like this, right? In the same way we will try to do the right hand side part and we see whether both are equal or not, right? Okay, sin square theta cos square theta. This we have got it as what? After cancellation we have got sin square theta into cos square theta, right? This is equation number 1 like this. Wonderful. Now we will take the right hand side part and we will try to do that. Fine. Now the right hand side part you take here like this. If you take this as now a5 minus a7 by a3 like this. This is also here a5 means sin power 5 theta plus cos power 5 theta, right, minus a7, that is sin power 7 theta minus cos power 7 theta, whole thing divided by a cube, a3 means what? Sin cube theta plus cos cube theta like this. Now in the same fashion here Let us take from sine power 5 theta and sine power 7 theta. We take common sine power 5 theta like this. Sine power 5 theta, if you take common, that become 1 minus sine square theta like this. Plus cos power 5 theta minus cos power 7 theta. If you take cos power 5 theta, if you take common, 1 minus cos square theta, right? Whole thing divided by, you have got here sine cube theta plus cos cube theta, right? And from this here 1 minus, right, sine power 5 theta into 1 minus sine square theta is cos square theta, plus cos power 5 theta into 1 minus cos square theta is sine square theta. Whole thing divided by sine cube theta plus cos cube theta, right? Wonderful. Now from this, you see, my dear students, from sine power 5 theta cos square theta, we can take common, which is common, and cos power 5 theta sine square theta. I think which is common means sine square theta cos square theta is common, right? Once if you take that as common there, right? Here what you are going to get, sine cube theta plus here you are going to get cos cube theta, this as cos cube theta like this. Whole thing divided by, you got here sine cube theta plus cos cube theta like this. Sine cube theta plus cos cube, this will cancel. Now you have got sine square theta cos square theta. This is now sine square theta cos square theta, right? And this is equal to the left hand side what we have got. That's way, okay, that is the way how you will be getting this particular problem, right? Fine, this is equal to left hand side, and right hand side equal to left hand side, or left hand side equal to right hand side. In this way beautifully you have got this problem, right, my dear students? Right, now this problem also, my dear students, you are many students having the doubt. This also secant theta equal to x plus 1 by 4x. We need to prove secant theta plus tan theta equal to 2x or 1 by 2x. See, this is secant theta, they given it as x plus 1 by 4x means let us take x by 1. Now secant theta is equal to, you take the LCM as 4x like this. Now by taking, right, this is now 4x square plus 1 like this, right? Now you see, my dear students, here what we do is you take right angle triangle, this is theta. Secant theta means hypotenuse by adjacent side. Hypotenuse is here 4x square plus 1. And this is 4x like this, right? Fine. And this is now something you have got it as A, B, C like this means, right? It is a Pythagorean triplet. Let us try to find BC. You know that BC square is equal to AC square minus AB square, right? AC square, that is nothing but 4x square plus 1 whole square minus 4x whole square like this. And that is equal to, see my dear students, once you got this, fine, this is equal to now what you are going to have, right? This is now 16x power 4 plus 1 plus 8x square, a plus b whole square, minus 16x square like this. And this is of course 16x power 4, 8x square minus 16x square, that is minus 8x square plus 1 like this. And this you can write it as 4x square minus 1 whole square like this, right? Of course then BC square is, this means BC you are going to get 4x square minus 1 like this. Because BC square is, this means BC is now this 4x square minus 1 you are going to get like this, right? Wonderful. After these steps, you will be getting tan theta, right? Tan theta, you know that that is opposite by adjacent. That means the perpendicular by base, right? Perpendicular by base, that is now 4x square minus 1 by 4x, right? Now secant theta plus tan theta we need to get. Secant theta plus tan theta you need to get. Secant theta equal to now 4x square plus 1 by 4x plus 4x square minus 1 by 4x, right? This is what? Now the LCM part is, you know that this is what 4x is what the LCM part, and from this you can get it 4x square, right, plus 1 plus 4x square minus 1. Minus 1 plus 1 will be cancelled, and that is now 8x square by 4x, 1x, 1x, 1, 4 2's. That means you have got it as 2x, right? You got it as 2x. They asked to prove either 2x or 1 by 2x, and we have got this as like this, right? You have got proved it as 2x, right? Fine. In this way you will be doing this particular problem. Okay, fine. Now they have asked to prove 2x or 1 by 2x means when we have taken BC, this is actually BC square equal to 4x square minus 1 whole square. That means BC equal to plus or minus of it. When you taken only positive one, now if you take BC equal to negative minus 4x square plus 1 if you take like this, minus 4x square plus 1 if you take like this. Now secant theta plus tan theta, what you are going to get, you see now this part you have, because the other thing you have here like this, plus of this is minus 4x square plus 1 by 4x like this. Now this is 4x you are having here, my dear students, 4x square plus 1 minus 4x square plus 1. Minus 4x square plus 4x square cancel, 2 by 4x. That means right, 2 ones 2 2s, 1 by 2x. You have proved this also like 1 by 2x. When BC is taking two things, plus or minus, right? Once plus if you take, you are getting 2x. Once if you take minus, you are getting 1 by 2x, right? In this way, you will be doing this particular problem. You see, the next doubt is eliminate theta if m equal to cosecant theta minus sin theta, n is equal to cosecant theta plus sin theta. You see, my dear students, how we do this particular eliminate theta means you have to totally eliminate theta. Theta should not appear. What mechanism? You use your mathematical and trigonometric rules to eliminate theta. Here you see, my dear students, m is equal to this they have given and n is equal to this they have given. Cosecant theta minus sin theta, cosecant theta plus sin theta. I think by looking this, just you will be getting an idea. The idea behind of that is, right, you see, for example, if I do something like I am going to use the formula a plus b whole square minus a minus b whole square. This is equal to, I am going to get, right, this is nothing but, you see, a square plus b square plus 2ab and minus a square minus b square plus 2ab, right, 4ab and minus a square plus b square minus b square, this is 4ab I am getting. Here if you take a as cosecant theta, if you take a as cosecant theta here like this and b as sin theta if you take like this, right. Now you see, my dear students, n square minus m square, this is equal to cosecant theta, right, plus sin theta whole square minus m square, that is nothing but cosecant theta minus sin theta whole square, right. This is equal to, now only we did, this is 4ab, that means 4 into cosecant theta, right, 4 into cosecant theta into sin theta, and you know that sin theta cosecant theta will cancel because cosecant theta equal to 1 by sin theta. That means you have got it as 4. Therefore this means you have got n square minus m square is equal to 4. This equation does not contain at all any theta. That means theta is eliminated and you got a relation nicely between n and m. Nicely you got a relation between n and m. This is the way how you are going to eliminate theta problems. Use some mathematical rules and trigonometric rules and try to make a disappearing of this theta, right? Now see, we have another problem. Sixth one, show that cos power 4 alpha plus 2 cos square alpha into 1 minus 1 by secant square alpha equal to 1 minus sin power 4 alpha. You see, like elimination of theta problems we will be doing in that way, right? Now you see, you have got this particular problem. How we are going to do this is, first of all, this is something like an identity problem. We have to check whether, first of all, is it correct or not, like this. This is now cos power 4 alpha plus 2 cos square alpha, they have given that, and this is 1 minus 1 by secant theta. 1 by secant theta is cos square alpha, like this, cos square alpha. This is equal to, now left hand side, this is what the left hand side you have got cos power 4 alpha plus 2 cos square alpha into sin square alpha, like this, right? Fine. And this is what left hand side, and you are having right hand side, you take this problem like 1 minus sin power 4 alpha, like this. That means this is now 1 minus sin square alpha into 1 plus sine square alpha like this. Now this is 1 minus sine square alpha is cos square alpha into 1 plus sine square alpha, right? Right hand side. And here you can take common even cos square alpha. If you take common 1 plus 2 sine square alpha, you are having here left hand side cos square alpha times 1 plus 2 sine square alpha, and this is right hand side part. This is what left hand side part, and this is what right hand side part you are having here. That's why, right, my dear students, here to prove this, okay, left hand side is not equal to right hand side. Here you are having 1 2 here, but here you don't have 2 here. That's why this 2 is should not be there in the material, right? This 2 is not there means then you will be getting this problem. This 2, you should not have this 2. Then only this problem will be correct. If 2 is not there, then you will be getting left hand side is equal to right hand side like this. In the material, it is given like a printing mistake. That 2 should not be there. Okay, this problem, if cosecant theta equal to x square minus y square by x square plus y square, where x comma y not equal to 0, x comma y belongs to real numbers, then prove that theta has no real value. Theta has no real value. It is very obvious, my dear student, that if you can observe cosecant theta, they given x square minus y square by x square plus y square, and you know that x square minus y square value is less than x square plus y square, because x, y are not equal to 0. Then you divide by x square plus y square, right? You divide by x square plus y square. This value will be, of course, what you are going to get. This is x square minus y square by x square plus y square is less than 1. This, and it lies between, since it is a positive quantity, here it is like a positive quantity, right? X square minus y square is lying between 0 and 1 like this, right? Once you have got, like, if it lies between 0 and 1, you know that cosecant theta value will never lie between, you observed its table, will never, cosecant theta value will never lie between 0 and 1 like this. This value will never lie between 0 and 1. That's why, okay, theta has no real value, therefore theta has no real value. It has no real value. In this way, this beautiful problem, we can do this, right? Now see one more problem. If minus pi by 2 less than theta less than pi by 2, but in material it is given it as e power minus pi by 2. That is wrong. It is, okay, it is only minus pi by 2 less than theta less than pi by 2. Then prove that cos of log theta is greater than log of cos theta. Let us take first the left hand side part. Here you have here cos of log theta like this. That means here theta is lying between minus 90 to 90, means logarithms are defined only for positive values. That means theta will be taking from 0 less than pi by 2, right? That means cos of log you are having here like this, log theta. Okay, it will never take negative values, it will take only positive values. Okay, if it takes positive values, logarithm you will have some value, some values you will be having here. Log of theta means 0 to pi by 2 means, and the pi value is 3.14. You know that from 0 to 3.14 by 2 logarithm it will be having some values. Okay, fine. This is something like 0 less than theta less than 1.5 or something like this. It will be going like this, 5, 6 or something. For these values, cos of any negative value will give you positive value. Cos of any negative will give you what? A positive value for this. Okay, left hand side you are having cos of any negative will be giving positive, because cos of minus theta become plus cos theta. You will be getting a positive value in the left hand side part. Now whereas you observe here, okay, fine, the right hand side part, if you observe the right hand side part, log of cos theta you are having here like this, log of cos theta, right? Now you see, my dear students, theta is lying from minus pi by 2 to pi by 2, means it is in fourth quadrant and first quadrant. In fourth quadrant and first quadrant, these values, right, these values what you are going to have, right, it lies between, okay, cos theta values will lie between minus 1 and 1 here like this. minus 1 and 1. Once cos theta values lies between minus 1 and 1, what you are going to have, and also right, cos theta lies between minus 1 and 1, log will never take negative values. Therefore, if you take 0 less than cos theta less than 1 like this, right? And if a cos theta values lies between 0 and 1, logarithm to the base 10, between 0 and 1, if you take 1 by 10, this become minus 1. Logarithm of 110 by 1 by 100, it will give minus 2. That means it will always give you negative value, because these are fractions and the base is to the base 10 or e also, no problem. It will give always negative values, and here you are getting positive values, here you are getting negative values, here you are getting positive values. Therefore, positive value always greater than negative value. Therefore, cos of log theta is greater than log of cos theta. Like this, we do this beautiful problem.